Hello, this is Mrs. Groves. Today I'm going to be discussing the answers to your 7.1 homework assignment, which was this homework assignment right here. It covered two sections actually. It covered 7.1, which means that our systems have one place where they intersect. It's one point of intersection, and you're going to get an ordered pair of x, y. The second section that's covered is 7.5, and those are special cases. So let's see how you did on your homework. Make this a little bit bigger. Okay. So you had to do problem number 1, right? And you are to write out the complete sentence. So the answer you should have here is a solution of a system of linear equations is two variables is an ordered pair that satisfies each equation in the system. For question number 2, I suggest that when you answer these questions, you can write them in kind of like bullet form. So the question was how to use graph and check method to solve a linear system of two equations and two variables. Step 1, graph both of the equations. Step 2, then estimate where they intersect, that point. Step 3, then go back and check that point in both of your original equations to make sure that your solution is correct. So that's number 2. Number 3 is a solution, and number 5 is a solution. And this is how you should be showing the work for these problems. So for number 5, you have 6x plus 5y equals negative 7. You replace the x and y. 6 times negative 2 plus 5 times 1 equals negative 7. And so negative 12 plus 5 is negative 7, which equals negative 7, and it checks. And then you check the other equation, which is x minus 2y equals 0. X is negative 2 minus 2, y is 1, which equals 0. So negative 4 is not equal to 0. It must check in both equations for it to be a solution. So negative 2, 1 is not a solution. Okay. For numbers 8 and 9, you were asked to find says solve the system graphically using the graph to solve the linear system. Check your solution. So for number 8, here's the graph, and the solution is 1, negative 3. Okay, in case you can't read that, it's 1, comma, negative 3. That was the solution. Then you were to take this solution, go back into your original equations, check them. It checks in both equations, so that is the solution. Now remember the odds, you're supposed to check those in the back of the book. So shouldn't have to go over number 9. Next question is number, 17. So here is the answer to number 17. Now remember, you can graph this using any method that you want. Okay, over here I did the check. Okay. I believe I did the check. So here, if you use x and y intercepts, you're going to get the x-intercept is 5, which is here. The y-intercept is 15. If you put it into y equals mx plus b, okay, if you put into y equals mx plus b, you should have y equals negative 3x plus 15. Okay, so there's the y-intercept, down 3 over 1. That's how you graph this line. Then the second line is this y equals negative 15. And that is a horizontal line at negative 15. So these are the equations, or you could have had y equals negative 3x plus 15. The solution where they intersect is 10, negative 15. You plug that 10, negative 15 into both equations and it checks. So that's number 17. The next problem is number 14. So you graph the two lines, y equals 2x plus 2. Right? So that's at 2. Excuse me. That's at 2. And then it goes up, slope of 2, up 2 over 1, or down 2, back 1. You draw that line. Then you have y equals 4x plus 6. There's the y-intercept of 6. The slope, I didn't want to go up, so I went down 4, back 1, down 4, back 1. And it intersects at negative 2, negative 2. Make sure when you do your graphs, you label the x and y axis. When you get your solution, you check both equations in the original to make sure that negative 2, that ordered pair is actually the solution. The next problem is 22. Give you a moment to look this over. First thing you had to do is put both of these equations into y equals mx plus b. Then you graph this one. The y-intercept's at 9. Slope down 2, back 1, down 2, back 1. Then you graph the other line. The equation of this line is y equals negative 2/3 x plus 5. Graph that line. Your solution is 3, 3. And then you check both solutions. Then you had to do number 23, which was an odd problem. Here's how you do it. So put it into y equals mx plus b, graph them, find the point of intersection, and then check them. So that is traditional systems that have one solution. Now, the next section that I had you do some homework problems was with regard to special cases. Okay. 7.5 is talking about systems of linear equations. And in this section, they're covering special cases. What I wanted to do now is cover the special cases that deal with graphing. So you had 4 problems to do here, 3, 4, 9, and 13. Okay. Question number 3. Ask to describe a situation when there's no solution. Well, if there's no solution, the lines are parallel lines. The lines have the same slope but different y-intercepts. Question number 4, give an example of infinite solutions. Well, the graph would only be one line. Right? The 2 lines would have, that you were given, would have the same slope and the same y-intercept. Okay. Then you had to do number 9 and 13. I was really nice because I gave you examples that were odds, but I just want to go over them. Okay. Number 9, you got this equation, y equals 3x minus 3. And if you take this equation and put it into y equals mx plus b, you get the same thing. So that means that you have infinite solutions. Same line, the solutions are all the points on the line. For number 13, okay, your graphs should look like this. They have the same slope, different y-intercepts, so the answer is no solution. So that's a review of the homework for 7.1, and that's it for now.